I hope everyone's doing good. I am Mr. Ish. Thank you for joining me for this very interesting question. It's a question here provided to me from a viewer. We have to show or verify the following. If a is larger than -1 and b is larger than a plus 1, then this improper integral ends up being convergent. What is the integral? From 0 to infinity, x to the power of a divided by 1 plus x to the power of b dx. We know two items. A is larger than -1. We know b is larger than a plus 1. You don't have to be overly creative. Just make a very good assumption with a. If you're working only with whole numbers in terms of no fractional values, let a be a value larger than -1, which would be 0. And then b would be larger than a plus 1, which would be larger than 0 plus 1. Therefore, b must be larger than 1. What's the next whole number larger than 1? It would be 2. So now we've established that a will be 0 and b can be 2, and then you can plug those into that and then compute. You will have an integral which is 0 up to infinity, x to the power of 0 divided by 1 plus x squared dx. But you can simplify this, so you can write this as 0 up to infinity dx over 1 plus x squared. And if you want, you can say limit as t approaches infinity, and then this right here can become a t, and we have a type 1 improper integral, and that's what it is. You know this right here represents an antiderivative in terms of the arctan or the inverse tan, and our answer here would be inverse tan. And then we're looking at it limit as t approaches infinity from t and 0, and you can easily look at the arctan graph. It's very easy. You have a horizontal asymptote here, pi over 2, you have a 0 comma 0 and a minus pi over 2. Your graph would look like this. Limit as values of x or t approach infinity, you have a value pi over 2, and here you'll have a minus pi over 2. So the limit exists. Here you have an arctan of an infinity, which we're writing here as t, minus arctan of a 0. This is us doing the definite integral part. Arctan of t or infinity is a pi over 2, minus arctan of 0 is a 0, and our end result is a pi over 2. It's a finite good value, so it's convergent, and we've shown this to be the case. So this right here was the assumption we made. A was equal to 0, and then we established b, and then we plug them in and we redefine our improper integral, the definite integral. We compute it and we have a convergent value. If a is any value larger than 0, then b will always be a value adjusted. You'll always have convergence. This was the base minimum values we looked using whole numbers, and we clearly verified this to be true. Have a good day and thank you.